Until now, we have fetched the data. What if I want to fetch the summary statistics? What do you mean by summary statistics? I want to fetch the how many number of rows are there in a table. I don't want to print all the rows. I want to know how many rows are there in a table. Or if there's a particular column called income, I want to know what is the average income. If there's a particular column called quantity, I want to know the sum of quantity, total summation of the quantity. If I want to get those summary statistics, how do we do that? So let us start with the number of rows. Again, the mantra is same. Select star from where. You remember that. Okay. Then you write select. Instead of star, you write count. Count is a function. Count star. If you write count star, that means it will be counting the number of rows from where, from whatever the table that you want to give. From products table, I want to select the number of rows, or I want to count the number of rows. So let us write down that command. Select count star. Select count star. Count is the function. Okay. From the table name. What is the table name? Products is the table name. If I execute that, the number of rows in that particular table will be printed. There are 110 rows. Count is a very useful command. Now this is counting the whole rows. What if you are interested in one particular column and you want to know how many rows are there in that particular column? Sometimes some columns will have null values, non-numeric values. I want to know the count of values, just the count, how many rows that particular column is present. You simply write select count that particular column name. You want to count the rows from a particular column point of view. Let's say product code. I want to know product code count. Okay. In how many places product code has been filled, I simply write select product code. Here, in all 110 rows, overall there are 110 rows. In all 110 rows, the product code is filled. Okay. Selecting the count from a particular column. Okay. What if I want to find the summation of a particular column? Right now, there is a column called quantity in stock. Can you see that column in the data set? Let's go to the data. Let us see. Once again, let us execute select star from products. There is one column called quantity in stock. In the stock, there is this much quantity. There are 7,933 motorcycles are there, Harley Davidson, 7,305. So there are a lot of quantity. What if I want to know the overall quantity? How do I write the command? Again, instead of count, I will use sum command. Okay, but summation should be done on the quantity in stock. So I will use sum quantity in stock. Quantity in stock. Select sum quantity in stock. That will give summation of that particular row. So here we are still getting count. Why are we getting count? Let us re-execute this. Select quantity in stock. The summation of quantity in stock is 55513. So nearly there are 0.5 million. Okay. 500 and 0.5 million. 0. Like 5,55,131 quantity is there. Okay. What if I want to know the average? There is a column called MSRP, price average. If I want to know, what will be the command for calculating the average? The average will be, you write AVG, that is the average. Then you write it MSRP. For MSRP, if I want to know the average, I'll write it this way, average MSRP. Let me select that carefully and execute it. Average MSRP is 100 point something. Okay. In fact, average value you can calculate by sum divided by count method also. Let's say if I find out summation of MSRP divided by count of MSRP, sum divided by count, that is also fine. That will also give us an average only. If I execute this, that also gives me sum divided by count 100 by this one, or directly average also gives me 100.438. So, but there is a direct method average available. There is no need to do that. Okay. Can we fetch the summary statistics for a particular group? Right now, I'm getting the overall count. Overall count. What if I want to get the count by a particular group wise count? Let me give you an example. For example, if I go to this product line, there are motorcycles, there are classic cars, there are motorcycles, classic cars, vintage cars, planes are there, trucks and buses are there. I want to know the count for each of these category. In product line, I want to group by product line. I want to get the count, but I want to group by product line. Then you have to use the command group by. So select count star from, what is the table name? Products. However, While you are selecting this, if you do that select count star, you will get all the complete count from the table. But you want to group by, you want to get the count for every group. Group by, what is the command? Group by which column? Product line. Group by product line. If you do that, then for every product line, you will get the output for every product line. Let us select it carefully for every product line 1, 2, 3, 4. But this is not easy to read. Instead of selecting only count star, let us also select product line. So the small modification that I'll do is I'll try to print product line as well as count star. If I select both of them, then first product line will be printed motorcycles, 13 are there, classic cars, 38 rows, trucks and buses, 11, vintage cars, trains, and all that. You can get the summary statistics by each group also. Let us suppose if I want to calculate count as well as average MSRP, count as well as average MSRP for each of this group, MSRP for each of this group, I can use this command. Once again, if I want to know the count and within motorcycles, what is the average price, then what I'll write, select product. Let me write it again for clarity's sake. Select product line, first of all, select product line, comma, count how many products are there, how many products are there, as well as average MSRP, average MSRP from products, from products. Select product line, count star, average MSRP from products. Looks like it is showing some error. Have you found where is this error? I have missed something. This is showing some products, some error. So here I have to write comma. By the way, if I do like this, I will get the complete count. Here we also need to add group by. Group by, what is group by command? Product line. For every product line, I want to fetch product line name, count, as well as average MSRP. If I execute this, I will get average MSRP also included. Okay. What if I want to order everything based on the count? If I want to order maybe based on average MSRP or average, or if I want to order it based on the count as well, then what you need to do is you need to give an alias. Okay. Let's say if I want to order it, okay. Now group by this, after group by, I want to do order by also. If I want to add order by count star, does that work? Order by count star. Let us see whether it will work or not. 3, 9, 11 and all that. Okay. Or if I want to say average MSRP, if I want to order by average MSRP, is that working? Check that out. Is that working? Average 73.86 and all that. But usually the column name is not that good to read. So generally what I suggest is the count star, that should be selected as frequency or count. Okay. And average MSRP as average price. Okay. Then order by average price. It's better to write it this way. It makes it easy to read. If you execute that, then average price will be printed. Okay. So that is the summary statistics: count, average, sum, group by, order by. That brings us to lab 3. If you have understood whatever we have discussed until now, as you may have observed, these are all very, very easy to understand and follow. If you're not able to understand, do them 2, 3 times. You'll be able to definitely understand. Once you have understood that, then write these queries on customers table. There is another table called customers. Have you seen that? Customers table, go to that customers table, then try to do these queries, write the queries for each of these questions. Question number 1. What is question number 1? Count the number of customers based on the customer number column. Question number 2, calculate the average credit limit by using average function. That is one method. Within question 2, there is another question. Also use sum divided by count method. Direct function as well as your own sum divided by count method. See what are the results, whether they are matching or not. Then question number 3, show the state-wise average credit limit. There is a column called state. State-wise, state 1, what is average credit limit? State 2, average credit limit. State 3, average credit limit. State 4, average credit limit. Then question number 4, show the state-wise average credit limit in each country as well. Here, state as well as country, both of them should come together. Okay, you have to use 2 conditions in group by. This is a little tricky. Do a little bit of internet searching, do some Googling and find out how to do that. And then order it by country name. You want to order everything by country name, either ascending or descending order alphabetically. These are the 3 commands. These are the 4 questions that you need to do as part of lab 3. Now let us get into our last topic in the first part of DML, that is joins. Joins is a very important concept. All of us must understand joins because data is kept in multiple tables. These joins will help us in fetching the data from multiple tables. Let's suppose if you are placing an order, in that order, there is payment related details. In that order, there is product related details. In that order, there is some customer related details. Product related details will be in products table. Customer related details will be in customers table. Payment related details will be in payments table. Address related details will be in some other table. So using joins, we can fetch the data from multiple tables which are related to each other. First, let us understand the concept of joins using a simple example. Let us suppose there are two sets of students. Set 1, Tom, Dan, Harry, Bill. These are the four students. They have taken Excel course in a university. In a university, they took Excel course. Or at our institute, they have taken Excel course. Tom, Dan, Matt, they have taken SQL course. Okay. So this is the set of students who took Excel course and these are their marks at the end of the course. And Tom, Dan, Matt, these are their student IDs. They have taken SQL course. These are their marks. Now here is requirement 1. Here is my requirement. Understand my requirement. I would like to see all the students from Excel course. I'm interested in those who have taken the Excel course. And if they have taken SQL course, if anybody from this list, Tom, Dan, Harry, Bill, if they have taken SQL course, I would like to attach those marks as well. Right now, I'm interested in Excel marks. That must be there for sure. Apart from that, if they have taken SQL course, that I want to attach here. For me, this is very important. So how many rows will be there in the resultant data? I would like to see all the students who took the Excel course. That means Tom, Dan, Harry, and Bill will be there. If they have taken SQL course, those marks, I want to attach them. So the table will have how many rows? Tell me. The resultant table will have only 4 rows because I want to take everybody from Excel course. And what is the extra column that you will have? SQL marks will be there. So for Tom, the marks will be 68. For Dan, the marks will be 80. Matt is not here. Harry did not take Excel course. Bill did not take Excel course. That will be a null value. Null value. This will be null. Null means nothing is there. Null means nothing or missing value or dot dot. That's it. This will be the resultant table. Everything from the left hand side table, I want to keep that. Everything from the left hand side table. If there is anything on the right hand side table, I want to attach it. This is known as left outer join. What is it called? Left outer join. Everything from the left hand side table, Excel course, and SQL marks that are attached with null values. This is known as left outer join. That is our first requirement. What if the opposite requirement? Can you understand the opposite requirement? The requirement number 2 is I would like to see all the students who are taking the SQL course. Let us suppose I want to know whomsoever taken the SQL course. First, I want to get their results. And by chance, if they have taken the Excel course, if anybody from here have taken the Excel course, I want to attach their marks. Finally, how many rows will be there in that with that requirement? If I create a table, how many rows will be there in the resultant table? I would like to see everything from the SQL table, SQL course. And if they have taken Excel course by chance, I want to attach their marks. So finally, I will have 3 rows, everybody from SQL table. And then if anybody, Tom, did he take Excel course? Yes, he did. So Tom will be mentioned as 90. Excel marks will be mentioned here, 90. Then Dan has scored 84. And then there is no Matt. Matt was not part of SQL, not part of Excel. He will be given as dot. So everything from the right hand side table we kept. If there is anything matching, that we have kept it from the left hand side table. Everything from the right hand side is given preference. Can you name this kind of join? What is this join known as? Everything from the right hand side table we are keeping it. That is known as right outer join. Everything from the right hand side table. In fact, if you swap the tables, if you keep SQL table here on the left hand side, if you keep Excel table here on the right hand side, then you can achieve the same thing using left outer join. In fact, left outer join, right outer join are almost same. Just that which table you are interested in, that is what you will be taking all the rows from that table. So the resultant table will look like this. Have you understood this? You focus on either left hand side or right hand side, one of the two tables. And if you want to keep what is your requirement base, sometimes the requirement would be keeping everything from this table. Then that will be left outer join. Sometimes the requirement will be keeping everything from this table. That will be right outer join. Okay. What if I have a different requirement? Understand this requirement. I would like to see all the students from these two tables who attended both SQL and Excel. I would like to see only those students if they have taken Excel course as well as SQL course, only those students. If a student did not take Excel course or if a student did not take SQL course, if they has taken only one out of these two courses, I don't want to see their marks. I want to see only the common students from both the tables. Those who have taken Excel as well as SQL course, that result I want to see. Tell me how many rows will be there in the resultant table. How many of them have taken both Excel as well as SQL? It is Tom and Dan. There will be 2 rows only. What will be the resultant table like? It will be S101, 102, Tom, their marks, as well as the resultant table will have only 2 rows. S101, S student number 102, student name is Tom, student name is Dan, Excel marks are 90 and 84, SQL marks are 60, 8 and 80. That is it. This will be the resultant table with just 2 rows and the respective column names: student ID, student name, Excel marks, and then SQL marks. So intersection area is what you are taking. If you are interested in knowing the data which is present in table 1 as well as table 2, keeping all the records from both the tables, that type of join is known as inner join. Inner join is slightly different. Outer join contains more data. Outer join, you will fix one table, the data from that table will be anywhere there. Inner join is only intersection data. Okay, that is requirement 3. Listen to the last requirement. The last requirement is I would like to see the details of all students. All students. It doesn't matter whether they have taken Excel course. It doesn't matter whether they have taken SQL course. It doesn't matter. If they have attended any one course, either Excel or SQL, if they have taken Excel course, put their marks. If they have taken SQL course, put their marks. If they have taken one course, if they have taken both the courses, then put both the marks. All the students who attended either SQL or Excel course, if that is the case, how many records will be there in the final data? It will be Tom, Dan, Harry, Bill, 4 plus 1. 5 records will be there. So the resultant table will have Tom, Dan, Harry, Bill, and Matt. For Tom, Dan, Harry, Bill, Excel will be filled. For Tom and Dan, SQL will be filled. For Matt, only SQL will be filled. So the resultant table will look like this, which will have 5 rows: Tom, Dan, Harry, Bill. For them, Excel marks are there. SQL is not present. For Excel is not present for Matt. For Harry and Bill, SQL is not present. Those are missing values. For Tom and Dan, both of them are present. This is known as full outer join. Full outer join means it is left as well as right. Left outer join, everything from the left hand side table as well as everything from the right hand side table. That is known as full outer join. Everything from left hand side as well as right hand side table. These are known as joins. Let us look at this further. As we discussed, if you take one order, if you take one orders from order table, let's suppose if you're going to a supermarket, one bill is known as one order. Now in one order there will be multiple products, isn't it? In one order there will be multiple products. You will be buying a soap, you will be buying a shampoo, you will be buying a chocolate, you will be buying multiple items. One order will contain multiple items. Okay, so from order, if you want to fetch the product details, then you have to use join scenario. Or if you look at it from the product's point of view, one product, let us suppose if you're talking about one shampoo or one product, one pencil or one pen, one product will be part of multiple orders, isn't it? You will not be the only person who will be buying one pen. There will be hundreds of pens, hundreds of soaps will be there. The product name is soap only. The product description is everything related to soap, but the same product description, same item will be part of several orders. You will be buying it, someone else will be buying it, several customers will be buying it. Let us understand these join scenarios in depth. What if I want to what if I want to get everything? The resultant table should have all the order details. I want to take every order. That is the right hand side table. This is right hand side table. And matching product details from the left hand side. Let's say this is the product code S18, 17, 49. I'll go to this products table. I'll go to this products table. I will check whether S18, 17, 49, that particular product item product code is there. If it is there, then I would like to get all the details from there. I would like to keep everything from the right hand side table. And then I want to match all the details from the left hand side table. Keep everything from the right hand side table. What kind of join is this? Keep everything from the right hand side table and bring the matching details from the left hand side table. What kind of join is that? That is right outer join. Everything from the orders table is mentioned here. Everything from the orders table is mentioned here. And then if there are some matching records from the products, that will be attached. If they are not matching, then it will not be able to attach. Okay. To do this exercise, let us take a single order. That will give us a good clarity on how to do this or what is the output. If you want reading the output, then it will be useful for us when you're doing the single order. Okay. Let me take an example of single order from orders table. So let me create a new table. Create table first. Look at this, then you can write it. So take a break, just look at this. Create table, one order details, one order only. I'm taking one order, create table. How do I do that? Select star from order details. Order details. First, let me do select star from order details. I would like to get one order only. So if I do select star from order details, all the order details are printed. Select star from order details. Okay. Now in that, I'll take only order number 10100. Okay. So I would like to create such table from order details where order number is equal to, what is order number? 10100. That's the order number. If I execute this, how many rows are here? Finally, how many rows will be there? Create table, one order, and then this. Let us print that table. The table got created. You will not get the output because we are not really printing it. Okay. So one order is the one table that I have created. Select star from one order is what we need to do. Okay. You can do it after me. First understand this. Select star from one order. So one order, this one order has product code, product code. It's possible, isn't it? Within one order, there can be multiple products. Within one invoice, you will have. It is possible that once you go to a supermarket, once you place one order, or even in e-commerce website, within one order, you can place 4 products. It's possible. Okay. This is that one order. Now what I want to do is S18, 17, 49. I would like to go to this products table, and then this particular product, the details related to that product, I want to fetch them, attach it to this table. Everything from this orders table, I want to keep it, and I want to get the product details based on the product code. So how do I do that? Let us do one join here. So select star from products. So here is the join scenario that I'm explaining you. Select star from products. There are two tables. What are the tables? Products and orders. Or within orders, so I am taking only one order detail. This is my table, one order products. Between these two, what is the type of join? This is the right hand side table. This is the left hand side table. I want to keep everything from the right hand side table. I'll write right outer join, right outer join, one order. Okay. Now, when you are joining two tables, there must be a way to go to this products table and then fetch the details or fetch the details. Product code is the joining ID. Product code is that ID that we need to combine these two tables. So join this right outer join on what? On what you need to join that? On product code. Okay. Sometimes here it is given as product code. Maybe in products table, it is given with some other name. So to be on the safe side, let us check product code here, product code here. You can write on product code directly, but a better habit would be go to products dot product code. Okay. Write it this way. What will happen is whatever is the name of that ID, that equal to within this table, one order, within this table, one order dot product code. Okay. One order dot product code. If I execute like that, then what will happen? There will be 4 items in this. For product code S18, 17, 49, those details will be fetched from here. If I execute this, the resultant output would be everything from the product code 17, 49, 22, 48, 4409. Product details, as well as order details. Look at the order details once again, all of you. What are the order details? You have order number, product code, order quantity, price, and all that order number. Since this is the right hand side table, all these columns will be on the right hand side. All these columns will be at the end. First, the product columns will be there, product related columns. All the product related columns, product code, product name, product line, etc., until this place. Then, what are the values from the order number, product code, quantity, ordered, price each. So there are only 4 rows because the right hand side table has only 4 rows. That is how the right outer join works. Go ahead, create this. You can pause this video, work on this. The next scenario, let us see the next scenario. That is, what if I want to keep the data from products table? Here, I want to keep all the data from orders table earlier. Earlier, everything from the orders table is what I want to keep. What if I want to keep everything from the products table and I want to see which product has been sold in which order? I want to focus on products table. And if there is any detail from the orders, it is not necessary that every product must be ordered. So if there is any data from the orders table, I want to attach it. Left hand side table is what I want to focus on. Then that will be called as left outer join. In the left outer join, you have everything from the left hand side table, which is the products table. And if there are any matching details from the right hand side table, they will be attached. If there are no details for some products, they are not part of any order, that will be left as blank. So the same exercise we will try to repeat, but this time we will try to focus on the products table. Once again, let us focus on one product. First, let me print the products table. Select star from products so that I will take one product just for a demonstration purpose. So 1678, S10 1678 is that one product that I want to take. Okay. What is the code for it? Create table, one product, create table, one product. I'm taking only one product. Select star from products table, select star from products table where product code, equal to S10 underscore 1678, where product code equal to S10 1678. If I execute that, then you will get one particular product. So let us print this one product. Again, select star from one product. If I execute this, what will be the output? The output is just one product, just one row. Well, I just want to see this one row, how many times in how many orders it has appeared. So only product code will be there, everything from the product code, and then everything from the orders I want to attach it. Okay, let us see in how many orders this particular product has been placed. It is possible that this one product code is part of several orders. It is perfectly fine. Okay, let us see that particular scenario. Let us write that code once again. Select star from, again there are two tables. First write down those two tables. One is products table, the other one is order details table. Order details, that is the set of tables, two tables. Now I want to get everything for this one product. That means the join, in this join, the important table for me. What is the important table for me in this join? The left hand side join. So that is left outer join, products table one, left outer join, the second table on which, on what I have to keep the join. In order details there is product code, in product also there is product code. On product code, product code. However, when you are doing this, you need to be careful. Product code may not be given as same column name in both of them. So in this case, what I generally suggest is you write one product dot product code that is equal to order details from all the order details dot product code. If you write like this, then this will be safe. Then when I execute this, the resultant output looks like this. Product code is single product code only, but it is part of several orders. One product code that we are focusing, but it is part of, there are different orders. This is known as one to many. One product code to many orders. Look at this order number. Somebody, customer, in this order, it is there, in this order, in this order, in several orders. Is it possible one product code is part of several orders? It is possible. This is known as one to many relationship. One product code is part of multiple orders. It's perfectly fine. Okay. That is the scenario of the left outer join. Left outer join gives us a scenario where all the left hand side table related data is there. Now let us go to the inner join scenario. What if I want to see, let us suppose there is a scenario where some product is never part of any order. Let us suppose you have this products table here and you have orders table here. There are some products that are not part of any of the order. Is it possible? And definitely there are some orders. Within an order, you cannot expect every product to be part of it. There are some orders that is not containing all the products. Okay. So what if I want to take intersection of both of them? If there is a product that is having in any of these orders, the products, here there is a product code. Here also there is product code. If a product code is present in both the tables, then I want to get the output. If a product code is part of products data as well as orders data, that intersection is what I want to get. That is known as inner join. If it is part of both this as well as this, it must be in products table as well as it, somebody must have placed an order, then only I want to fetch it. It must be present in both the tables, then I want to fetch it. Then that is called inner join scenario. Okay, let us do this inner join. Let us write the code for this inner join. Select, this inner join is easy. Select star from, again write the two table names. One is products. Select star from products is the first table. The order doesn't matter in inner join because intersection is coming. Products and order details. Order details. These are the two tables. What is the type of join in between? Both the tables should contain that row. Inner join. Inner join. On what? What are you combining? What are you joining on? On, simple, on products dot product code is equal to order details dot product code. If I execute this, this will be the result. Let us see how many rows are there in that result. To get an idea on the number of rows, if you go here, 1000 rows returned. Is it really 1000 rows? Let us check. How do you get to see that? Select count star also fine. Let me do select count star. Let us see whether that will work or not. 2996 looks like 1000 rows got printed because limit is 1000, but it actually returned 2996 rows. Okay, select count star. But the actual command is select star from this. Okay. What if I swap them in an inner join? The order doesn't matter. If you put order details first, and then if you put products next, does that matter? It doesn't matter. Let me do, first of all, let's execute this. This will work. The order doesn't matter. Hey, what's the error? Let us see. Inner join order details. By the way, one product. We have done some error here. It should not be one product. It should be product. Is it? Yep. Let me check that once again. Did we do that error? Now let us see the count star. Looks like there was some error. One product. Did I change it? Hopefully I have changed. 2996. That's fine. Okay. Now we will go here and then select star. We have changed the order now. Order details and product. That is working fine. Let us see the count here. Since I told you the order doesn't matter, here also it should be 2996. Again, it should be 2996 only. 2996. So in inner join, because we are getting the intersection between these two, it doesn't really matter. The last scenario is full outer join. That means if there is a product code, we don't really care whether somebody has ordered it or not. I want to get all the details. Okay. If there is an order number, we don't really care whether we have any details of that particular product. There is some product here, but that is not part of this products table, but still I want to print it. Everything from the products table, everything from the orders table, I want to do the full outer join. Now this is little tedious. First you need to do the right outer join, get the details. Then you need to do the left outer join, get the details. Then you have to combine both of them using union all. In some other programming languages, there is something called full outer join directly available, but here you have to do it in a roundabout manner. Let us do the full outer join here. First, you do the left outer join or right, any one of them. Select star from table 1, table 2. Both of them are joined by right or left, right outer join. Okay. Orders and products. Okay. Now what you will do is, you're not yet done. Below that, this is the right hand side table. Everything from the right hand side table it will fetch. Then fetch everything from the left hand side table. Okay. So get everything from order details. That is the first set, first code snippet. Get everything from the product. Okay. That is the second code snippet. After that, you have to say these two results. In between, you put union all. Remember, this is all single command only. First, right outer join. That means get all the right means what? Right means right hand side table, product details. Then left outer join, get all the order details. First get the products, then get the orders, then do a union all. Then when you execute this, then the output will be somewhat like this. This is the output that you will have. Okay. What if I want to say, I want to create a table out of these, then see the select count star on that table. So let me call that as create table full join, or instead of saying that name, I'll give product and order details, prod orders full. If I give this name, create table, both of them, create table. You remember the create table syntax? The same way you write create table, create this table with these conditions. So if I execute this, it will execute create table from select star from and all that. Duplicate column product code. Looks like product code column has been selected. Select star from this one as well as select star from this one. It is giving us an error product code. I'll tell you how to avoid the duplicate. Maybe this we will do it a little later. Maybe right now to fetch the output quickly, I will just do select count star. How do you avoid that duplicate column code that is coming up at a later point? There is a small concept that we need to discuss. Then we will reach there. First, as of now, I will see select count star. Okay. Right outer join. Okay. Here, if I put count star, that won't work. Why it won't work? The reason is we are selecting some of the columns here and those columns are in use. If I'm using just count star, if I'm not selecting some of these columns, then we will not be able to do the union and all of that. Okay. So how do you get to know whether how many rows are there in this output? Let us have a look at it. First of all, it's working. The output is giving us the result. But how do I get to know how many rows are there? Because there are only 1000 rows that are printed. There is some point, there is some place where you will get this particular information mentioned there. Okay. So once you see this, Here 5993 rows are returned. Can you see that? 5993 rows are returned. How do you know whether this is correct or not? It is simple. Whether you do first left outer join or right outer join, it doesn't really matter. If I swap this, first if I do the left outer join, later if I do the right outer join, let's say let's put left outer join first, then right outer join. It doesn't really matter because you're taking the union. Full outer join means everything from the left outer join means orders everything from the products. So it doesn't matter. The order doesn't really tell us how many results are there. So here also finally, if you see the output in the output window in the compiler, this is the output window, 5993 rows are returned in the full outer join union. I'm going to tell you how exactly you create a table here. The same column has been selected twice. It is saying that product name is same. So then we have to rename it or alias it or we have to drop it. But as of now, we are just fetching the output, selecting the rows from this one as well as the order table as well as the products table. Okay. There are a few more commands that are coming up. Actually, when we get into data definition language, we are going to see some more details of how do you handle such issues. One of the issues was column name has to be unique. The other constraints will be sometimes the column should have non-null values. Sometimes the column should have numeric values only. So those kind of details we are going to see in the upcoming session, next session. As of now, this completes our discussion on joins. That is our last topic in DML part in this particular session. That will bring us to lab 4 in joins, append all the customer details. Right now we have worked with orders and products. I want you to experiment with customers and orders. You can do all type of joins. You try to take customer details and order details. First fetch all the customer details, attach order details. Maybe you can take one customer ID and try it out. Then the second option would be get all the order details, only attach the customer details to that. Maybe for one order you can do that. Then you try inner join, then you try outer join. Try to perform joins on these two set of tables, customers as well as orders. That concludes our first set of DML commands. The upcoming sessions are DDL commands or data definition language. How do you create a table and all that? Here we worked with already available table. What if you have to create a new table by yourself? That is DDL. Again, we will get into some more details of DML part 2 advanced version. Then we will get into DDL part 2 advanced version of DDL as well. These are upcoming sessions. As of now, you practice whatever we have discussed until now. Thank you, everyone.